December 23, 1941. Wake Island, Central Pacific. Civilian construction workers for Morrison Knudsen Company huddled in makeshift shelters as Japanese bombers pounded their positions for the third consecutive day. They had been building a military outpost on this tiny coral atoll when war erupted 2 weeks earlier. Now they crouched helplessly while Marines returned fire with the few weapons available. International law prohibited civilian contractors from fighting. If they picked up weapons to defend themselves, they could be classified as guerrillas and executed upon capture. The Geneva Convention offered them no protection as combatants. They could only hide, hope to survive, and pray for rescue that would never come. On December 23rd, Wake Island fell to Japanese forces. The Marines who defended it became prisoners of war under Geneva Convention protection. The civilian construction workers had no such protection. Several were executed immediately. The rest were shipped to prisoner of war camps in China and Japan, where many died from disease, starvation, and systematic abuse. Of the 1,146 civilian contractors on Wake Island, 98 were executed and hundreds more died in captivity. The tragedy demonstrated a critical gap in American war planning. The United States Navy needed to build bases, airfields, ports, and supply depots across thousands of miles of Pacific Ocean, and needed to build them in combat zones where Japanese forces could attack at any moment. Civilian contractors couldn't do this work. They were defenseless, unprotected by international law, and vulnerable to summary execution if captured. The Geneva Convention offered them no protection as combatants. The solution emerged from Rear Admiral Ben Morrell, Chief of the Bureau of Yards and Docks. On December 28, 1941, just 21 days after Pearl Harbor, he requested authority to create something unprecedented: military construction battalions. Combat-trained engineers who could build anything, anywhere, under fire. On January 5, 1942, authorization came through. The new units would be designated construction battalions, abbreviated as CB, which quickly became Seabees. Admiral Morrell personally supplied their official motto, Construimus, Batuimus. We build, we fight. Their unofficial motto was simpler, more defiant, and would become legendary: can do. What emerged was unlike any military unit in history. These weren't soldiers who learned construction. They were construction professionals who learned to fight. Carpenters, electricians, heavy equipment operators, plumbers, engineers, welders, and skilled tradesmen of every description enlisted. The Navy waived the maximum age limit to 50 years to recruit experienced professionals. Some men past 60 managed to enlist by lying about their age. The average age of early Seabees was 37, ancient by military standards, where most combat troops were 18 to 25. Many had families, established careers, and comfortable civilian lives. They volunteered anyway. They understood that someone had to build the bases from which America would fight back across the Pacific, and they understood that whoever did that building would be working under fire. Japanese military intelligence monitored the formation of these construction battalions with reactions ranging from amusement to contempt. Construction workers in uniform? Middle-aged civilians playing soldier? The Imperial Japanese Navy employed professional combat engineers, young, fit, military-trained specialists who had built fortifications across the Pacific. The Americans were sending plumbers and carpenters to fight a war. The Japanese stopped laughing in September 1942.
August 7, 1942. Guadalcanal, Solomon Islands. The 1st Marine Division landed on Guadalcanal in the first American offensive operation of the Pacific War. Their objective: capture the partially completed Japanese airfield and deny its use to enemy forces. The Marines secured the airfield within 48 hours, but capturing it and making it operational were entirely different challenges. The Japanese had begun construction but left the field incomplete. The runway measured only 2,600 feet, too short for bombers and barely adequate for fighters. The surface was rough dirt and coral, not smoothed or compacted. Drainage was inadequate. Heavy rains would turn it into impassable mud. There were no fuel storage facilities, no ammunition magazines, no maintenance facilities, no nothing. On August 12th, the captured airfield was renamed Henderson Field, honoring Major Lofton R. Henderson, the first Marine aviator killed at the Battle of Midway. The Marines' 1st Engineer Battalion began immediate work using captured Japanese equipment, bulldozers, graders, and roller compactors the enemy had abandoned in their hasty retreat. They worked around the clock, filling bomb craters, extending the runway, and attempting to compact the surface enough for aircraft operations. By August 18th, 11 days after the invasion, Henderson Field was minimally operational. The first aircraft to land were 19 F-4F Wildcat fighters and 12 SBD Dauntless dive bombers launched from escort carrier USS Long Island. These 31 aircraft formed the core of what would become known as the Cactus Air Force, the heroic hodgepodge of Marine, Navy, and Army aircraft that would defend Guadalcanal for the next 4 months. But the Marines' engineering work was barely adequate. The runway remained too short. The surface deteriorated rapidly under combat operations. Every time it rained, and in the tropics it rained constantly, the field became a muddy morass that damaged aircraft landing gear and caused as many losses as enemy action. Enter the Seabees. On August 1, 1942, the 6th Naval Construction Battalion landed on Guadalcanal, 387 men and 5 officers in the 1st contingent. They had traveled from Espiritu Santo with one mission: complete Henderson Field and keep it operational no matter what the Japanese threw at them. They arrived to find conditions that would be considered impossible for construction in peacetime. Japanese bombers attacked the airfield almost daily around noon, always the same time, always from the same direction, flying in perfect V formations at 20,000 feet altitude. Japanese warships bombarded the airfield almost nightly with naval gunfire. Japanese ground forces launched repeated attacks attempting to overrun American positions. The defensive perimeter was so close that enemy artillery could shell construction sites directly.
The Seabees set to work anyway. They dug in immediately in a narrow strip of coconut grove adjacent to Henderson Field, establishing quarters under constant threat of artillery fire and aerial bombardment. The next day, work details took over airfield construction and maintenance, while other crews began building fuel storage facilities, ammunition magazines, and maintenance hangars. The work became a never-ending race against destruction. Japanese bombers would crater the runway with high explosives. The Seabees would fill the craters, regrade the surface, and have the field operational again within 40 to 60 minutes. Japanese warships would shell the field all night, cratering the runway and destroying fuel storage. The Seabees would work through dawn repairing the damage before the next day's flight operations. One Guadalcanal veteran recalled, "With their skills, they were able to repair damage done to the runway of the airfield by Japanese bombing within 40 to 60 minutes." The Seabees developed innovative solutions to maintain operations under fire. They created special repair trucks, preloaded with gravel, Marston matting, perforated steel planking, tools, and compaction equipment, mobile repair units that could respond to bomb damage in minutes. Crews staged materials at multiple locations around the perimeter, so attacks on one supply dump wouldn't halt all repairs. They worked under conditions of unimaginable stress. Malaria infected nearly everyone. Dysentery was endemic. Tropical ulcers ate through skin and muscle. Dengue fever struck randomly. Food supplies ran critically low, with Marines and Seabees alike reduced to 2 meals per day consisting largely of captured Japanese rice. And they worked under fire, constantly. Seaman Second Class Lawrence C. Bucky Meyer became the first decorated Seabee hero of the war. In his off time, he salvaged and repaired an abandoned machine gun, which, on October 3, 1942, he used to shoot down a Japanese Zero fighter making a strafing run. For this exploit, he was awarded the Silver Star. It was a posthumous award. 13 days later, Meyer was killed when the gasoline barge on which he was working was struck by Japanese naval gunfire. Despite losses, despite disease, despite constant bombardment, the Seabees kept building. They extended the runway to 3,800 feet, then cleared and graded another 1,300 feet. They surfaced the entire length with Marston matting, interlocking perforated steel planking that provided a stable, all-weather surface capable of supporting heavy bombers. On September 9, 1942, the Seabees opened a second runway approximately 1 mile east of Henderson Field's original runway, doubling the facility's capacity and providing redundancy against bombing attacks. The transformation was extraordinary. What the Marines had captured as a partially completed, marginally functional dirt strip became a major airbase capable of supporting continuous combat operations by fighters, dive bombers, and eventually heavy bombers. Henderson Field became the pivot point of the entire Guadalcanal campaign. American aircraft operating from the field struck Japanese supply convoys, attacked enemy positions, and provided crucial air cover for American forces. The Japanese made repeated, desperate attempts to recapture or destroy the airfield. They understood that whoever controlled Henderson Field controlled Guadalcanal. The Seabees ensured America controlled it. Japanese commanders watching reconnaissance photos struggled to understand what they were seeing. How could the Americans repair bomb damage so quickly? A direct hit that should have closed the runway for days was repaired in an hour. Extensive shelling that should have rendered the field inoperable had no lasting effect. What kind of construction capability did this represent? The answer was simple, brutal, and effective. Skilled American construction workers, military-trained and combat-ready, working under fire with determination that matched any frontline infantry unit. The Henderson Field experience taught American planners crucial lessons about the Seabees' capabilities. But an even more dramatic demonstration was about to occur. May 1943. Guadalcanal, Solomon Islands, now secure and serving as a major American base. Marine Fighter Squadron VMF-214, the legendary Black Sheep Squadron commanded by Major Gregory "Pappy" Boyington, needed a forward operating strip closer to enemy positions. Combat radius was critical. Every mile closer to Japanese bases meant more time over target and better chances of intercepting enemy bombers before they reached American positions. The Seabees received orders: build a fighter strip, build it fast, build it where we tell you. The location selected was a jungle-covered hillside on Guadalcanal's northwest coast, about as far from ideal construction sites as possible. Dense jungle growth, uneven terrain requiring extensive grading, no existing infrastructure, no roads to bring in equipment. Everything would have to be built from scratch in terrain that seemed specifically designed to prevent construction. The 73rd Naval Construction Battalion took the job. They landed heavy equipment using pontoon barges, another Seabee innovation that allowed rapid deployment of bulldozers and graders without port facilities. The equipment drove directly from the barges onto the beach, then began the overland journey to the construction site through jungle that had no roads. The Seabees cut roads as they advanced. Bulldozers knocked down trees while engineers surveyed the route. Behind the bulldozers came graders smoothing rough paths into roads capable of handling heavy equipment. Within hours, a supply route existed where there had been only jungle. At the construction site, work began immediately. Bulldozers with specialized jungle clearing blades knocked down trees faster than anything the Marines had managed with captured Japanese equipment. The Seabees had modified standard bulldozer blades, adding weight and angle to slice through tropical hardwoods that would stop conventional equipment. Stumps were blasted out with explosives. Uneven terrain was graded and compacted. Coral was crushed and used as a base layer for the runway surface. Marston matting, thousands of interlocking steel planks, was laid over the compacted coral, creating an all-weather surface capable of handling fully loaded fighters taking off for combat missions. The Seabees completed a functional 3,000-foot fighter strip in 72 hours. 3 days, from raw jungle to operational airfield. The speed was so extraordinary that even American commanders questioned the reports. A fighter strip in 3 days? Surely that was a typographical error. Perhaps they meant 3 weeks. But the reports were accurate. Marine fighters landed on the new strip exactly 72 hours after construction began. Pappy Boyington's Black Sheep Squadron operated from that field for the remainder of their deployment, intercepting Japanese bombers and fighters with combat radius extended by precious minutes that often meant the difference between successful interception and enemy aircraft escaping into the clouds. Japanese intelligence officers analyzing reconnaissance photos from the period documented their confusion in captured reports. American airfields were appearing faster than seemed possible. Intelligence estimates for airfield construction based on Japanese engineering experience suggested weeks or months. The Americans were building functional bases in days. The psychological impact was significant. Japanese commanders planning operations had to account for the possibility that any location might have an operational American airfield within days of being secured. The Americans' construction capability had become a strategic weapon, infrastructure that appeared faster than Japanese forces could destroy it.
The Seabees' success stemmed from innovations that revolutionized military construction. Rear Admiral Morell's Distinguished Service Medal citation captured this perfectly. Displaying great originality and exceptional capacity for bold innovation, he inspired in his subordinates a degree of loyalty and devotion to duty outstanding in the naval service.
Marston matting, officially designated pierced steel planking, PSP, was developed specifically for rapid airfield construction. Each section measured 10 feet long by 15 inches wide, weighing 66 pounds. The steel was pierced with 87 holes for drainage and weight reduction. Integrated hooks and slots allowed sections to interlock, forming a continuous surface that could be assembled with sledgehammers. Seabees could construct a runway 200 feet wide and 5,000 feet long within 2 days using these mats. The material proved so durable and versatile that approximately 2 million tons were produced during World War II. The advantages were transformative. Traditional airfield construction required months of surveying, grading, and paving with concrete or asphalt. Marston matting could be laid directly over compacted coral or dirt, creating operational runways in days instead of months. When airfields needed to be abandoned, either from strategic withdrawal or advancing beyond the operational range, the matting could be recovered, transported, and reused elsewhere. On Adak Island in the Aleutians, bulldozers scraped sand over a tidal swamp and laid down pierced steel planking. 4 days after an amphibious landing, a 3,000-foot runway was operational. In Vietnam, Seabees repaired the airfield at Khe Sanh, covering an area of 3,900 feet by 60 feet with aluminum matting in 4 days.
The Navy's Magic Box, a 5-foot by 5-foot by 7-foot steel pontoon developed under Admiral Morell's direction, became one of World War II's most versatile pieces of military equipment. These standardized steel boxes were buoyant, could be assembled in virtually any configuration, and proved adaptable to countless uses. Some 520,000 of these boxes were built during the war, and as many as 45,000 were used in a single landing operation. Joined together, the magic boxes formed causeways for landing troops and vehicles directly from ships to beaches, floating piers for unloading cargo where port facilities didn't exist, floating dry docks for emergency ship repairs in forward areas, bridges spanning rivers and channels, barges for transporting equipment and supplies, seaplane ramps for naval aviation operations, and rhino ferries, motorized platforms that could transport tanks and vehicles from ships to shore. The Seabees pontoon innovation was adapted for amphibious warfare. At Sicily, the beaches were considered impossible for amphibious landing by both Allies and Axis. The Seabees, with their pontoons, proved that was not true. After an invasion, the magic box was used to construct self-propelled barges, floating dry docks, seaplane ramps, and bridges, which further enabled the flow of logistic support. The modularity was genius. The same standardized box could serve completely different functions depending on how Seabees assembled them. This eliminated the need for specialized equipment for each task. A single type of component handled countless applications.
Traditional civil engineering viewed coral as a problematic construction material, too hard to excavate, too irregular to provide stable foundations. The Seabees turned coral into an asset. Seabees learned to judge coral's various qualities, taking moisture conditions into account in order for it to compact and set effectively. Well-built coral runways were found to require less maintenance and equipment than airstrips composed of any other local material or even pierced steel planking. The technique involved crushing coral into various sizes, mixing the crushed material with specific moisture content, then compacting it into incredibly durable surfaces. When properly prepared, coral runways could handle heavy bomber operations without the extensive maintenance required by dirt or other natural surfaces. One innovation that became legendary in Seabee lore: using Marine Corps armor-piercing tank shells to blast coral formations that were too hard for conventional explosives. If dynamite wouldn't break the coral, high-velocity armor-piercing ammunition fired from tanks would shatter it into pieces that could be crushed and used for construction.
The Seabees developed operational methods specifically for building under fire. Dispersed supply caching. Rather than maintaining centralized supply dumps vulnerable to single attacks, Seabees staged construction materials at multiple locations around construction sites. One bomb hit might destroy one cache, but work could continue using materials from other locations. Mobile repair units. Preloaded trucks equipped with everything needed for emergency repairs: gravel, steel matting, hand tools, compaction equipment. These units could respond to bomb damage within minutes, repairing craters and getting airfields operational again before follow-up attacks arrived. 24/7 shift operations. Continuous construction regardless of time. When one crew exhausted themselves after 16-hour days, relief crews took over immediately. Equipment operated around the clock with mechanics performing maintenance between shifts. Integrated defense. Unlike civilian contractors who couldn't fight, Seabees were trained in combat. Every Seabee battalion had integral defensive weapons, typically 6 5-inch naval guns, plus machine guns and small arms. When Japanese forces attacked construction sites, Seabees defended their positions while continuing work during lulls in combat.
The scale of Seabee construction across the Pacific defies easy comprehension. By war's end, construction battalions had served on 6 continents and constructed over 300 bases on as many islands. In the North, Central, South, and Southwest Pacific areas, the Seabees built 111 major airstrips, 441 piers, plus countless roads, bridges,
fuel storage facilities, ammunition magazines, hospitals, and housing for hundreds of thousands of troops. At peak strength, the Seabees numbered over 325,000 men, organized into 151 regular construction battalions, 39 special construction battalions, dozens of construction battalion maintenance units, or CBMUs, and multiple naval construction brigades coordinating large-scale operations. Individual construction battalion detachments, or SBDs, numbered from 6 to 600 men, performing specialized tasks from running tire repair shops to operating dredges, manufacturing pontoons, or setting up pipelines. The variety of work was extraordinary. Seabees built everything military operations required, from airfields from coral atolls to jungle hillsides, deep water ports where none existed, hospitals treating thousands of wounded, fuel storage facilities holding millions of gallons, roads through impossible terrain, bridges spanning rivers and gorges, water purification systems, power generation facilities, communication infrastructure, even ice-making plants for tropical bases. The invasion of Okinawa alone took 4 construction brigades totaling 55,000 men. The scale of that single operation exceeded the entire peacetime Navy construction force.
The Seabees' motto, "We build, we fight," wasn't mere bravado. They fought and died alongside combat troops. After the experience of Guadalcanal, the Department of War decided that Marines and Seabees would make all subsequent landings together. That arrangement meant Seabees frequently came ashore in the first waves of amphibious assaults. On D-Day at Normandy, Seabees were the first ashore as Naval Combat Demolition Units, NCDUs. Their task was to remove German defensive beach obstructions built to impede amphibious landings. They came under very heavy fire, but were able to detonate their charges, opening gaps allowing the assault to land. Construction mechanic 3rd Class Marvin G. Shields of CB Team 1104 fought at the Battle of Dong Xuai in Vietnam in June 1965. He was posthumously awarded the Medal of Honor and is the only CB to receive the award. The casualty statistics tell the story of the Seabees' combat exposure. Over 325,000 Seabees served during World War II. Approximately 400 were killed in action. Thousands more were wounded, and many more died from tropical diseases that ravaged Pacific forces. These numbers seem small compared to infantry casualties, but they reflect that the Seabees' primary mission was construction, not combat. The fact that 400 Seabees died in action demonstrates how frequently they worked under fire and how often construction sites became battlefields.
Japanese military intelligence documented their evolving assessment of CB capabilities in captured reports translated after the war. Early assessments from 1942 reflected contempt. American construction units composed of overaged civilians with minimal military training. Intelligence summaries predicted they would be ineffective under combat conditions and vulnerable to attack. By late 1942, the tone had changed. Reports noted with alarm the speed of American airfield construction. Japanese engineers estimated that the Americans were building in days what should require weeks. The intelligence couldn't explain how this was possible. By 1943, Japanese planning documents routinely included assumptions that any island captured by American forces would have operational airfields within days. This assumption fundamentally changed Japanese defensive strategy. They couldn't prevent Americans from building. They could only attempt to destroy completed construction faster than it could be rebuilt. They failed at that too. The Seabees proved capable of repairing damage faster than Japanese forces could inflict it. At Henderson Field, Seabees repaired shell and bomb holes faster than the Japanese could make them. One captured Japanese officer,
interrogated after the Battle of Guadalcanal, expressed frank admiration mixed with frustration. "Your construction forces are not soldiers, yet they fight. They are not young, yet they work harder than young men. They build what we destroy before we can destroy it again. How do you defeat an enemy who rebuilds while under fire?" The answer, from the Japanese perspective, was that you couldn't. The Seabees represented industrial capacity and construction capability that Japan simply couldn't match. Japanese combat engineers were skilled and dedicated, but they operated with limited equipment, constrained supply lines, and under constant Allied air attack. The Seabees operated with unlimited equipment, robust supply chains protected by American naval power, and growing air superiority. The industrial disparity that characterized the entire Pacific War was visible in microcosm through construction capability. America could build faster than Japan could destroy. That imbalance made ultimate Allied victory inevitable.
The Seabees proved principles that remain relevant in modern military operations. Specialized military construction forces are essential. The need for a militarized naval construction force to build advanced bases in war zones was self-evident after Wake Island. Modern military forces still employ dedicated construction units. The Navy Seabees continue today as the Naval Construction Force, maintaining the legacy of their World War II predecessors. Skilled labor multiplies combat power. The Seabees demonstrated that specialized skills, carpentry, electrical work, heavy equipment operation, welding, have military value equal to combat skills. An expert bulldozer operator under fire is as valuable as an infantryman because that operator creates infrastructure enabling all other operations. Innovation under pressure produces results. Marston matting, pontoon causeways, coral construction techniques, these innovations emerged from operational necessity. When conventional solutions didn't work, the Seabees improvised. Bold innovation in the face of a determined enemy, and often without sufficient tools or material, became a hallmark of the Seabees. Rapid infrastructure deployment is a strategic weapon. The ability to build airfields, ports, and bases faster than enemies could destroy them proved decisive. Modern expeditionary warfare still depends on this principle. Forces that can rapidly establish infrastructure in austere environments gain overwhelming operational advantages. Today, the Seabees remain among World War II's least celebrated units. Popular memory focuses on Marines storming beaches, fighter pilots engaging in dogfights, submariners stalking enemy convoys. The construction workers who built the bases enabling all those operations receive far less attention. Yet without the Seabees, the Pacific War would have been impossible to prosecute. Every Marine division that landed on hostile beaches depended on Seabees to build the logistics infrastructure supporting operations. Every fighter pilot who flew combat missions from forward bases operated from airfields Seabees had built, often under fire, frequently in days, always under impossible conditions. The numbers tell the story of their contribution. 111 major airstrips, 441 piers, over 300 bases across 6 continents, countless roads, bridges, fuel facilities, hospitals, and support infrastructure. All built by construction workers who traded comfortable civilian lives for the privilege of building under fire in service of their country. As Admiral Morrell noted in 1962, "I believe an important factor contributing to that spirit was the emphasis on the fact that ours was and is a service organization, that it is our job to help the other fellow get his job done, and that the extent to which we helped him was an accurate measure of the value of our services." That service-focused mentality, building not for glory but to help others accomplish their missions, characterized the Seabees throughout the war and continues in naval construction forces today. The Japanese officers who initially laughed at middle-aged construction workers in uniform learned harsh lessons about underestimating American industrial capacity and can-do determination. Those overaged carpenters and plumbers built infrastructure that enabled American victory across the Pacific. They built airfields in days that should have taken months. They repaired damage faster than enemies could inflict it. They constructed ports, roads, and bases that transformed coral atolls and jungle islands into operational military bases supporting hundreds of thousands of troops. They did it all under fire with determination, skill, and a simple motto that explained everything: can do. The Japanese stopped laughing about the Seabees sometime in 1942. By then, American airfields were appearing across the Pacific faster than Japanese forces could destroy them. The construction workers they dismissed as a joke had become the engineers of Japan's defeat, building the infrastructure that brought American power to Japan's home islands. From Henderson Field to Iwo Jima to Okinawa, the Seabees built the road to Tokyo, not with bullets, but with bulldozers. Not through combat, but through construction. Not as warriors seeking glory, but as builders enabling victory. They remain the forgotten heroes of the Pacific War, the men who built the bases from which others won battles. Their legacy endures in every modern military construction unit, in every rapid airfield deployment, in every forward operating base established in hostile territory. The Seabees proved that in modern warfare, construction capability is combat capability. The side that can build faster, repair quicker, and establish infrastructure more rapidly gains advantages that tactical brilliance alone cannot overcome. Japan learned that lesson through dozens of American airfields appearing across the Pacific in days rather than months. Built by the construction workers they'd dismissed as a joke, had become the engineers of Japan's defeat. Building the infrastructure that brought American combat power to Japan's home islands. Can do.
In memory of the 325,000 Seabees who served during World War II, the construction workers who became warriors, who built while under fire, and who enabled American victory through infrastructure constructed faster than enemies could destroy it. Their motto remains their legacy: Construimus, Batuimus. We build, we fight.